Let's look at a circle with radius r. Creating a sector, we have the two sides of length r, the arc length L, and the angle theta. A radian, similar to a degree, is a unit of measurement for angles. As the angle changes, the value of degrees and radians, which describe that angle, also change. Let's say that the circle has a radius of 10 centimeters and an arc length of 20 centimeters. Then we can fit exactly 2 radii inside this arc. We therefore say that the angle created by this sector is 2 radians, because the arc length is the same length as 2 radii. The formula for describing this angle is theta is equal to L over r, where theta is the angle, L is the arc length, and r is the radius. Let's take a look at an example. Say we have a circle with a radius of 8 centimeters and a sector making an angle of 1.5 radians. How would you calculate the arc length? You may need to restructure the formula from before to find the unknown L. Rearranging the formula to find L, the arc length, we have L is equal to theta multiplied by r. Filling in this formula with our angle as 1.5 radians and our radius as 8 centimeters, we get an arc length value of 12 centimeters. In real-life applications, time becomes an important factor. Take, for example, a ball on the end of a string of length 4 meters. If the ball moves along a distance of 2 meters, using the formula from before, you could describe the angle created as 2 over 4, or 0.5 radians. However, we can also consider the time it takes to create the angle. This describes the angular velocity of an object, which is denoted by the symbol omega and is measured in radians per second. The formula for omega, the angular velocity, is v over r. So, using the same example as before, but assuming it takes 2 seconds for the ball to move 2 meters. As the ball travels 2 meters in 2 seconds, our velocity is 1 meter per second. Substituting this into our formula, we get 1 meter per second over 4 meters. This gives us an angular velocity of 0.25 radians per second. Let's say that the ball from before is moving at an angular velocity of 1.5 radians per second. How would you calculate the velocity? You may need to restructure the angular velocity formula to find the unknown v. Rewriting the formula to find the velocity, we see that the velocity is equal to the angular velocity multiplied by the radius. Substituting in the values, we get 1.5 radians per second multiplied by 4 meters, giving us a velocity of 6 meters per second. Let's work through a full example. Say we are looking down at a ball at the end of a string, which is being spun horizontally in a circular motion. Within a period of 2.5 seconds, if the initial position and final position of the ball create an angle of 1.5 radians, and the string is 2 meters long, find the distance the ball travelled in this time period. Then, find the angular velocity of the ball. Focusing on the first part, try to find the distance the ball travelled. Using the formula to find an angle in radians, we rearrange to find the arc length L. Substituting in the values, we get a distance of 3 meters. Now, looking at the second part of the question, try to find the angular velocity. Using the first formula to find the ball's velocity, we substitute in 3 for the arc length and 2.5 for the time period. This gives us a velocity of 1.2 meters per second. Next, we calculate the angular velocity by filling in the second formula with the values for the velocity and the radius, giving us an answer of 0.6 radians per second. So, to summarise, a radian is a unit of measurement for angles. A radian describes how many radii fit inside the arc length at a certain angle. The formula for an angle in radians is theta is equal to L over r. The angular velocity describes the change in angle over time and is measured in radians per second. The formula for angular velocity is omega is equal to v over r. And then we looked at a couple of worked examples. That's all for this lesson. See you in the next one.